Good morning, everybody. I appreciate everybody attending today on this Friday morning. My name is Hunter with Gasvoda. I've been here about 11 years. I want to thank GPSD for allowing us to have this here once again. Today we have my good friends Tony and James presenting on Lagoons and understanding the operations. Should be a good presentation here for everybody. So without further ado, I will let them take the stage here. Thank you.
Okay. All right, good morning, everybody. Thank you for attending. Before I turn it over to Tony, who's going to jump in Lagoons, I just wanted to give a quick introduction on who RCAP is. So we are the Rural Community Assistance Program. We're a national non-for-profit. We work in all 50 states, plus Guam, Puerto Rico, and the U.S. Virgin Islands. I've been trying to get transferred there for a couple years, but to no avail. What we do is we offer managerial, technical, and financial assistance to rural communities. When we talk about rural communities, what we mean is communities 10,000 or under, and that is our only qualifier. And we are fully grant funded through 3 federal grants, so that means that we can offer every service that we offer at no cost to any community whatsoever, as long as they're under that 10,000 or under. When we talk about managerial assistance, what we can do is we can do things such as board trainings, working with your board to understand what their roles are, what the stewards are to their water wastewater system. Managerial or technical, we have Tony on staff. He can work with your operators one-on-one. We can offer technical assistance. We're also able to do trainings like this one. We offer several trainings throughout the year with organizations such as this, also several online as well. And you do not have to be 10,000 or under to attend those. There is no population cap. And again, those are always going to be at no cost. When we talk about financial, what we talk about is things doing such as rate studies, both on the water wastewater side, so people kind of understand what their cost of production is, what it's costing to run that water system, maybe if we need to adjust any rates in the future. We can also offer assistance with access to funding. So we've been doing this for a number of years. We know what the funding resources are. We kind of know the language, so we can kind of work with you to gain access to that funding. We will never fill out the application for you, purely because by the time we got all the information we need from you, the application would have already been filled out. So, but we will work with you one-on-one. We can tell you the different type of assistance types within the community and what's out there for the government. And what's available right now. We can do income surveys, so if you work in a community and you're going for any sort of grant or loan assistance and you think that your numbers aren't quite adding up to the census website, we've seen a lot of that, especially since the ratification of the 2020 census the last couple of years. We can go through and assist you with that as well. We can, work to kind of figure out what the true income and what the true scope of the project is for that community. We do environmental reports. So if you are going through a funding project and you need environmental or NEPA done, that is something that we can do as well. We can go through, we'll contact all the agencies, all the governments, and even the tribal contacts that need to be made, we can do that as well. So that's kind of a little bit of the basics of what we do. Yeah, so we work a little bit everywhere in the state. We have 5 people right now. Me and Tony are here today. Then we have someone based in Chicago, someone based in Stell, Illinois. I am based out of Lincoln, and then we have someone else based out of the Springfield area, and someone in Mahomet. So we're a little bit everywhere. Also, we did recently receive a new grant. In the last couple of years, we became an environmental finance center. What that means is we are now allowed on special projects to work with communities 10,000 or over. So if you think that we have something that we can assist you with, go ahead and talk to me, even if you're a little bit bigger, because we have the potential to be able to help you under that environmental finance grant as well. It kind of took some of our population caps off. Our main grants are still 10,000 or under. And then another service we do offer is we do GIS work. Unfortunately, our grants don't cover that, so that would not be at no cost. There would be a small fee attached to that, but if it's something that you're not GIS'd and you'd be interested in learning more about what we can offer you on that side, Again, feel free to go ahead and reach out to me and we'll kind of discuss it. I have cards over there at the end of the day. Some of you did get flash drives. Those are part of one of our funding grants. What they do have is materials for both the state of Illinois and actually from all our regions. So all 50 states contributed a little bit of something to them. They're yours to take. Feel free to take them home, plug them in your computer, and to see some of the materials that we had to offer. With that, I'll turn it over to Tony, who's going to jump into lagoon operations. He's going to do that. And then afterwards, I'm going to do a presentation on decentralized wastewater systems, just kind of an introduction to the concept of what they are and kind of how the basics of how they work. We see some of them in the state of Illinois, and it's becoming a little bit more popular, so it's kind of a interesting topic. And this training was approved for 2 CEUs today, so we'll have that. So we have that information as well. All right, Tony.
That's why. Yep. Okay. My name is Anthony Brown, Tony Brown. Some of in the audience know me, some don't. I'm actually a local guy here. I started my career at Glassford, Illinois, where I live, as a water and wastewater operator. About 2019, Glassford's water and wastewater was bought out by Illinois American, so I did some time there. Went on to become public works director in another community locally here, and I have transferred into this position to do technical work for RCAP in the last year and a half. Unfortunately, I'm guessing Lagoons is going to be a little bit of a boring subject for some of you guys that are running oxidation area activated sludge, class 1, class 2 systems. And when we were talking about what presentations that we can do for this HOI group of operators, it was requested to do Lagoons. So I'm going to give you an overview of Lagoons. Some of it will be very basic and kind of like if you guys were going and taking class 4 operations. This training is actually built around this training is actually built around trying to enlighten, say, boards, village boards, and assist the operators in trying to help elected officials understand the asset at hand and how it's supposed to work. So there's a little bit more engagement, a little bit more organization between the operator themselves and the people that control the purse strings on what they can spend to try and help manage the lagoon correctly and keep it operational. So James talked about, there's a few slides here of what we do. Again, this is a national program. This is a national program, and some of the things. Our group is our region, the Great Lakes region. We're based out of a headquarters in Ohio, but they do have dedicated employees in the state. And again, I'm here locally. I have business cards up here for anybody that needs to talk technical, and you guys fit within our realm. Generic, our mission, improve surface water protection, environmental compliance of water and wastewater. The EPA funds us, US EPA. Go back. Oh. I feel like I'm because of this camera here. I'm trying to get in front of everybody. So again, we have to put these things in our presentations because that's who pays us to do these trainings. So again, we've got a couple people that we need to get some pictures of up here. Myself and James. I am a licensed water and wastewater operator. I do have experience in class 2 systems. I'm not a class 2 operator. I was going to go take my exam when Illinois American bought our place, and they told me I didn't need to, and so I haven't had a requirement to since. So, but I do have fairly serious experience in Class 2, and I was going to go get my exam right during the buyout. So, I am a Class 3. I'm a Class B water operator with time in an A system. So, and we've done introductions, overviews. We're going to talk about lagoon types, aeration methods, lagoon design configurations, roles of algae, thermal turnover, pros and cons of lagoons. There is tests. We're not going to issue any tests, but there is tests in this training. So we'll kind of skip over those slides. One of the items when we were asked to come do this training was a question on feedback to you guys on herbicide chemicals to use around lagoons. Unfortunately, because of our federal funding, we're not allowed to endorse any certain brands or things along those lines. But I wanted to make sure that in that conversation that I did elaborate when we get to it of kind of what you should look for when you're trying to do weed control. So, commonly interchanged terms: lagoon, oxidation pond, stabilization pond, polishing pond, maturation pond. So we have 3 types of lagoons: anaerobic, facultative, and aerobic. Facultative is essentially a combination of aerobic and anaerobic zones, which most of these operators in here, I believe would be. Am I out of the picture? No. What you guys would, especially with dealing with activated sludge, where your guys are, you're doing your different zones within your oxidation ditches and things along those lines. We know with the treatment of wastewater, in order to get full treatment, we need a combination of aerobic and anaerobic processes in order to completely provide that treatment. There's a little operator that can do about an algae and effluent of a wastewater pond. However, they may help if the ponds are operated in series, parallel, tandem, or none of the above. I'm not necessarily looking in this training to test you guys on there. We would control the algae in series. You know, we would try and contain the algae into one particular cell where that activity is taking place as part of the treatment process. So here's some different applications: aerobic, facultative, and anaerobic. So anaerobic is commonly used in industrial wastewater. You're loading of your BODs or CBODs. Typical detention time in days that you're looking for, typical depths and comments. Subsequent treatment normally required, which, I mean, again, to truly fully treat wastewater, you're going to need a combination of aerobic and anaerobic. So, again, a lot of places are using facultatives, or they're selling it out in series in order to get those zones taken care of. So, facultative is common. Raw municipal wastewater effluent primary treatment, trickling to going to trickling filters or aerated ponds or anaerobic ponds. Aerobic, generally used to treat effluent from other processes, produces effluent flow in soluble BODs and high in algal solids. You know, so there is some aspect into there why you would pick one versus the other. So, do we have any lagoon operators in here? Okay. You want to talk about your lagoon at all? Good old Farmington? No? You're running facultative out there, right? So, common in Facultative lagoons, again, it's about a balance. A lot of times these facultative lagoons are one cell. You have an, is this a pointer? No. Yeah. You have a influent coming into the pond. You're based in zones. Your facultative bacteria and anaerobic bacteria are intermixed among the zones. It's very common around that 8-foot to 10-foot level in facultative lagoons. That's kind of where they're designed at anymore. I haven't seen any deeper than that. Doesn't mean that they're not out there. So we want, in those facultative lagoons, we want both processes happening. Lagoons themselves operate, and facultative lagoons operate on a diurnal cycle. Anybody know what a diurnal cycle is? Day-night cycle. So you are going to have, in these facultative lagoons, you're going to have DO changes throughout the day. As the sun operates through the course of the day, your algae growth increases, and it's going to put more dissolved oxygen in the water. So at the end of the day, at sundown, your DO is going to be highest coming out of your pond, and then as the night goes through, those anaerobics start, those aerobics can start using that DO up, and by first thing in the morning, your DO is going to be as low as going to be. So it operates, those facultatives operate on that cycle. And again, it's about balancing the bugs, having your anaerobic zones consuming some of the solids at the bottom where you're not seeing that DO, because your DO is going to be primarily up in that top layer. Anaerobic lagoons, used mainly for the treatment of high strength or commercial wastes. It lacks dissolved oxygen throughout. The treatment depends on fermentation of sludge at the bottom. It's highly effective in destroying organic wastes. Depths are typically 8 to 14 feet. Effluent requires further treatment. And again, that's because you're going to have your ammonias and your nitrogen content coming out of that anaerobic environment. And now you need the algae coming into and consuming that. That algae growth that's spurt is consuming the NH3. It's taking that in and actually building more cellular, doing the dividing of the cellular microbial algae. Take a poll in the anaerobic portion of the facultative pond. Organic matter is converted into carbon dioxide and ammonia, and then into algae in the presence of sunlight. True or false? Anybody? Methane is usually produced in the anaerobic. So, again, facultative lagoons, we have the bacteria. This is a 3 to 8 foot facultative lagoon. I've never seen one that shallow, but that doesn't mean they're not there. This is just part of the training project that we're given, that we go through and we alter. Having the anaerobic and aerobic bacteria mixed in. Again, the anaerobic portion is a lot of times breaking things down. That's where your methane gas comes from. Methane gas has hydrogen and nitrogen and carbons in it. That's part of that process. Your ammonia comes out of that, and then you're using that algae to break that down further. So, anaerobic bacteria, this is a sludge blanket, and this is one of the things about operations that a lot of lagoons aren't properly managed. I have seen the worst lagoon I have ever seen in my life recently within the last year in a small community in Waste, is almost as far south in Illinois as you can go. This is an 8-acre lagoon that was built 50 years ago that's had absolutely no sludge management. 8 foot deep, at least 7 foot of that, there was only 1 foot of freeboard is sludge. It is red. Everything is dead, just like a red tide. That primary cell, that 2-acre or 8-acre cell, that primary cell has just got water going into it. Nothing's happening. And then the water coming out into the second cell. In the second cell, it's turned into nothing but an algae bloom, and that water's pea green. And this is what they're discharging. Well, needless to say, that's why the IEPA and the IEPA are there right now, because there was no activity for a long time. And we got called in to help them try and find funding so they can do dredge work and get rid of that sludge so they can actually get the lagoon operating again. So that anaerobic bacteria sludge blanket needs to be managed, whether it's use of enzyme pellets or some sort that's going to help break that solids down that's settled in that sludge blanket, break them down further so it doesn't build up, because again, you need that photosynthesis zone above in order for that algae to complete the process and allow your effluent to be clean. So again, talking about Faculty of Lagoons contains all the treatment process in one cell or a series of cells that provides benefits of improved treatment, operates via the diurnal day-night cycle treatment variants. Daytime, I'll go back. Daytime sunlight promotes algae growth and thus treatment, providing supplemental dissolved oxygen. Nighttime continues overnight with the anaerobic treatments below, consuming DO created during the day. However, other anaerobic increases throughout the night as well. So abnormal operations occur when ponds are overloaded due to high BODs. This can be caused by what? What'd you say? All the above. That is correct. Any one of those things can increase your BOD requirements. So aerobic lagoons, again, that's the use of dissolved oxygen coming in, providing the treatment. Dissolved oxygen throughout all depths, not just zoned off. May use aeration devices to create supplemental oxygen when they're not, there may be some depth to it, so that it's not enough sunlight. Maybe it's turbid. Oxygen can penetrate the wastewater. Used for domestic and industrial wastewaters, low and medium strength, aerated. Keep hitting the wrong button. Aerated lagoons require less land and shorter detention times. Just a couple examples of aerobic lagoons. Another pole, during the day, the algae in a pond consumes carbon dioxide, which raises the pH, while at night they produce carbon dioxide, which lowers the pH. True or false? True. Part of that process of the algae in taking ammonia out of the water also consumes carbon dioxide. It's photosynthesis. Yes, I'm kind of having a little. As those algae cells grow and divide and create more algae, that's what's consuming the carbon dioxide that's being produced by the anaerobic. Plus, it's producing DO to go back into your aerobic. So again, that change in carbon dioxide will change the pH. Aeration methods, mechanical or diffused. I'm assuming most of you guys are, there's only a handful of lagoon guys here. What aeration do you employ, Mike? Wind? Common? You guys got a lagoon? Okay. Air compressor, diffuse type? Okay. Okay. Turbulence, disturbance? Okay. So I actually had one of these in Glassford that was horrible because in the wintertime that stainless steel gets cold and it turns into nothing but an ice block. One of the things that I changed before Illinois took over, in the waterfowling world, which I am a duck hunter, Mike's also a duck hunter, they make this device called an ice eater that is very good for putting in and pulling water from the bottom and pushing it up to the surface. So during freezing temperatures, we can keep an open water hole for our hunting. Well, I actually took one of those and installed that into my lagoon to actually keep that process, because he's talking about wind. Wind going across the pond actually puts DO into your lagoon. So if you can keep open water in the winter, that was one of the aspects that I used in order to keep my DO up. Any questions? One of these? Yeah, I had it sink. That literally turned into an ice chunk and started doing this, and it went, I mean, burnt the motor up, everything. So, yeah, I don't recommend these aerators whatsoever. They need to do away with these. They may work good in Florida, but not in Illinois in January. There are some other examples of mechanical aeration. Again, using a pump to disturb the water column and provide that if you think there's absolutely no wind and there's no wave action on a pond, there's still a little bit of dissolved oxygen transfer in there, but it's that wave motion that some of those things that produce actually, or even the fountains. So there is, Illinois American has a system in Washington at Washington Estates at one of those. It's been a while since I've been there. Maybe Shannon's been there in a while. They actually had an ornamental fountain in a lagoon, or they have a class 2 system there, but they have a settlement pond that's coming out of that, and they actually had a ornamental fountain there in the middle of the neighborhood in one of those lagoons. Provided DO, kept the water open. So mechanical aeration horizontal. This is actually very close to an aeration version that I had at the Lakeside plant that I had in Glassford, where we were using, I ran extended aeration ditches, and we had paddle piece like this in both ditches that actually beat dissolved oxygen into the water. Stir agitation, diffused oxygen through compressed air being plumbed out through a distribution plumbing system. So surface aerators are used to provide additional air for ponds during the night, during cold weather, in overloaded ponds. Truth of the matter is, it's all the above. In that process, you've determined, in order to make sure the treatment process steps are being healthy, you determine you need DO. These are one of the methods you would seek to put in. More examples of diffused aeration. Small inlets to let small bubbles out. Aeration and energy efficiency. Aeration can be 50 to 60% of the energy used as a wastewater treatment plant. If you're running a gravity system, like you would with a lagoon, you may only have 1 or 2 pumps, but you're also running an air compressor to diffuse aeration. It could be a sizable portion of your energy costs. So thinking about properly using the pneumatics and hydraulics to the most efficient advantage will help you overcome some of your financial issues. Doing good maintenance and keeping it running efficient. Coarse bubbles versus fine bubbles. Fine bubbles can be 35% more effective versus coarse bubbles. The smaller the bubble, the better your oxygen is going to dissolve within the liquid. Blower size data, raw dust, or raw data versus effluent data, evaluating what your influence, your effluence, and maybe picking some place in the process of doing another test. How do I look here? Design flows versus actual flows. Do you automate? Do you figure out where your parameters are? Do you automate and add DO sensors that would in some of these processes kick your aerators on and off? VFDs. Summer versus winter treatment. Think Earth. The less power you use and the more you can use gravity and you can use wind and you can use some of those effects, the cheaper your electrical costs. 5 bubble aeration affects bubble size. The smaller the bubbles, the larger the surface area to volume ratio. The slower the bubbles will rise in water, meaning more contact time. Increase in clean water oxygen transfer rate. Fine bubbles, again, 35% increased in the transfer. Lagoon configurations, we talked about series and parallel. Having series where you're going to have, say this is a primary cell. This is more of a cell where you're going to do some polishing, and maybe this is a final cell along there. Or they do it in parallels. And it really, that means all 3 of these would be doing the same functioning, and you're just dividing your inflow load of treatment across. So, Mike, what do you got for your configuration? You just one pond? Secondary? Okay, so you're doing a polishing in a cell 2 percent. Okay. So limitations of wastewater ponds are odors, high suspended solid levels in the effluent, treats waste inconsistently, may contaminate groundwaters, requires large area of lands. What do you think they are? All the above. So you can have odors come out of lagoons. I can tell you in Glassford, the last thing you wanted on a nice warm spring day after winter is having a west wind coming off my lagoon going to town. Because as the ice comes, if I wasn't successful in at least keeping some open water out there and it froze over during the winter, I was going to have a methane buildup. And when that ice came off, it stunk. Sulfides. I don't agree wholeheartedly with the high suspended solid levels in the effluent. To me, that's, you don't typically see that. It can happen as you get some turnover. So, but to me, that's part of a solids management program within the lagoon. Some of that gas can build up, and you can get flock coming up from the sludge bed in that lagoon. And as that comes up, it can then break up, and because those particles are basically a little bit buoyant, just a hair buoyant, and they can stay and be turbid. but it's not often you see that. But lagoons, they require volume. They require sizable land. I mean, we're talking Glassford, okay? That lagoon that I had only took care of half a town, and that was a 2-acre lagoon. So lagoons in series have advantages. Few algae and bacteria in effluent in the end, and the idea is to reduce short-circuiting. So short-circuiting is an important feature of lagoons everybody needs to consider. We talked about in series. I have a particular lagoon I'm working with as a homeowners association over by Morton, and they have one lagoon that actually has cell blankets dividers across it and is breaking that up into 3 different cells. I am in the process of trying to put some financing together, because while I'm monitoring with their operator right now what their data says, I'm not 100% convinced that there's not some sort of short-circuiting occurring, that water coming into cell 1 is skipping cell 2 because there may be a hole in the curtain barrier somewhere. Okay? That water's designed to come into cell 1, go through cell 1, go into cell 2, go through cell 2, and then go into cell 3. Well, if you have water short-circuiting, that some of that water is not being treated to its capacity that it's supposed to be. So, disadvantages of in series: the first lagoon in the series experiences the heaviest, especially solids, right? So that can become anaerobic when you don't want it to become anaerobic. So again, that goes back to that sludge blanket management program. How do we manage that? How do we keep our sludges minimalized and the right processes versus having some done in parallel or a single pond? Parallel, the advantages: can take heavier loads without becoming anaerobic. Again, that's an example of one inflow being divided across 3 ponds. So now you've got your solids loading divided across 3 ponds. You can also, in where you have that capacity, you can close one lagoon off and just operate off of 2 and get your maintenance done. The other disadvantages is it may not produce as good as an effluent as a series of arrangements because you're not controlling that process. We can't underestimate algae's role in lagoons in consuming the ammonias and consuming the carbon dioxide. We can have algae's blooms grow and really mess up our operations. Algaes produce solids, so your TSS could be off. They can build up, like this one's got duckweed. Now it's cutting out the photosynthesis that should be taking place. The general rule of a lagoon effluent is clear, sparkly, with a slight green tint. That is good health of the lagoon. You have just a little bit of algae growing there, and it's keeping things in check. So one other thing that lagoons, how far are we in? Can you tell? We should be getting pretty close, I thought.
Yeah, but we are 9:45.
I'm just trying to decide if I need.
We're right at 40 minutes.
Okay. So thermal turnover. Again, we talked about winter operations versus summer operations. They're a lake. They have thermal turnover. That can create suspended solid issues. It could disrupt the zones that you're trying to build. So that is something that needs to be taken in effect and in thought process and management. That bottom water will rise into the top water column. and it takes time for anything that it's brought up with it to settle out. Generally speaking, the colder the pond contents, the more effective the treatment process. True or false? False is correct. Pros of lagoons: life expectancy. As long they can go longer than 50 years if that sludge blanket's managed, and you're at least doing some level of management of what your bug activity is doing. They're simple to operate and maintain. They're the lowest licensing requirement in the state of Illinois. Little to no energy requirements, limited with pumps and aeration. Other than that, you're letting nature do its work. Cost effective to design and construct where land is inexpensive. It's effective at removing pathogens. Effluent can be suitable for irrigation and can handle shock loadings better than most systems. In reality, they can handle a sizable hydraulic load shock compared to an oxidation ditch, especially. Cons of lagoons: require more land than other treatment methods, less efficient in colder climates, may require additional land or longer detention time. They can have odor control issues. They can provide breeding areas for mosquitoes, which there's some techniques we can talk about. Not very effective at removing heavy metals. Those are going to settle out, and depending upon what type of influent that you're trying to treat, that can be a concern in some areas. I can tell you in my past, prior to my moving into Glassford's system, they had naturally occurring radium-226, 228 coming out of their potable well water. They built a treatment system to remove that. Guess what happens in that treatment system when you backwash? Where's that condensed radium-226, 228 go? Right down to the sewer plant. So that created issues for us about the time I moved in, where I'm removing sludge from a class 2 plant, and it has radioactive issues. This is no longer, this ain't even a class B sludge to get rid of. At that point in time, we were trucking it to some landfill down by East St. Louis that could contain that. We couldn't even go take sludge over to Macomb at that point. We had to truck it all the way down there. So their sludge management and this treatment, heavy materials, heavy metals like that, can have an effect. So effluent may require additional treatment to meet local discharge standards. Again, that's about lagoon management. What kind of lagoon you got? What's it designed for? What are you trying to do with it? You're trying to do too much with it, it's not going to do that. You would then require additional. Common lagoon issues: weeds and long grass, short-circuiting, wind and scum, erosion, burrowing animals, and sludge accumulation. So this is where I was going to come in with the emails that went back and forth between our group and your group. I can't condone a specific product on weeds around lagoons. What I can tell you is weed management around lagoons should be done. They create habitat for burrowing animals. The last thing we want is muskrats and beavers and stuff eating holes into our lagoon walls or dikes and giving them a high grass area to hide. So there are chemical products out there that are safe to use and spray weeds around the aggregate that may be at the shore level layer, trying to keep burrowing animals from, that won't negatively affect the algae. So try and look for those types of products. Short circuiting, again, that's really a design issue or component of the design issue. whether you're having the skirting that's breaking one into and channeling the water. So you may have to actively look at your baffling system to make sure that you're not short-circuiting in areas. If you're short-circuiting, you will start seeing an uptick down at your effluent of various things. Why is my TSS going up? Why is my BOD going up? What it's going to have an effect up there. Wind and scum, again, I recommend, like in this particular, they've added mechanical aeration in there to at least keep the duckweed down. I would probably look at booming this off. Anybody know what booming off duckweed is? Creating some sort of rope and flotation system. So lagoons, most of the lagoons that I see are sizable. 2 people, we can tape 500 foot of rope. We can go get pool noodles, thread that through the rope, start at one end, come up both sides, trying to drag and push that blanket up and try and get it pulled up onto the shore to where it can be dried out all the way. So I can get the photosynthesis, not just have to rely on the mechanical. I can get the photosynthesis taking place with the algae, and I can get the wave action. If I get too much of that scum up there, I'm not getting the wave action. I'm not getting the DO from that. Erosion, not having proper bank protection. You can see up here, there's some rock along this side. I can't tell in this photo if there's rock along here, but while we want wind action on the lagoon, we don't want to erode the banks. We want to keep control of that. Sludge accumulation, I jumped too quick. Sludge accumulation, again, I've hit on a lot. Don't let that bank build up too much. There are enzyme products out there that you can buy that it's I throw pellets in and I try and evenly displace them across the bottom of the pond, and I let those enzymes that promote that bacterial growth consume those solids down. Inlet to a pond should be blank to distribute the heat of the influent as much as to minimize the occurrence of floating material. Anybody? Submerged. We don't want that. We don't want that raw influent into the lagoon coming out into the open air. We want it injecting into the pond below the surface. Short circuiting we talked briefly about. Okay, this is one unit. Short circuiting means the water's flowing here and basically flowing through here. Now we've got a dead spot in that lagoon here and a dead spot in that lagoon here. So how would we baffle it to make it more serpentine to go out and get that right detention time? Because when you start short circuiting, that's a quicker line through. Wind and scum. So sometimes wind can be your friend. When you do have scum, use that to your advantage when it blows down to one area. And again, we talk about that boom off method. You may be successful in taking that floating device, just like an oil boom, containment boom, and pulling it, tying it up to a vehicle, and pulling that material up on the bank and get that out of there. Erosion and burrowing animals, obviously this is not a good thing. Weeds and long grasses, again, giving that habitat to those animals to hide. And you wouldn't even see the burrows. So operator should use blank as a last resort for weed control due to hazards facing the operations and the dangers facing biological growth in the pond and reviewing waters. Be careful with the herbicides. Some herbicides will not work well with a lagoon. They'll kill off your life. Kill off your life as quick as chlorine will. Clean looking lagoon routine maintenance inspections. Preliminary treatments, most common, some sort of headworks with grit removal. No primary treatment at all, but screening is desirable. Screens remove large solids so they're not getting in there. Influent flow rate can be measured if there's partial flume there. Operator's responsibilities, clean and maintain, check the diffusers, make sure everything's working. Fouling of diaphragms, biggest drawback to using compressor diffusers. Cleaning and preventative maintenance is the answer. Using diffusers for this kind of, I think, should have been up a little bit. Diffusers, distribution of air, look for dead zones. Huge rolling air bubbles or side of blown diaphragms in those. We're getting pretty close to time here, so I need to jump forward. Okay. Okay. When starting a new pond, at least 1 foot of water should be present before waste are introduced when possible. That would be true. So we're basically here at the end. I'm still developing this slide. I was talking with Shannon earlier. I actually did a version of this at a homeowners association here about a month and a half ago. And I'm bouncing some of this information around a little bit, and I need to do a little bit better job with this. So you guys got any questions on lagoons? Unfortunately, it's kind of a boring subject for most of you guys. Nothing? Bueller? Okay. Well, I'm going to yeah, okay. You want me to show this?
So we'd like to thank Tony for coming down here and taking the time to teach us about lagoons. We are going to take a 5-minute break and we'll set up for the second presentation of the day.
No.
on the podium. All right.
Okay, we're ready to start our second part of this presentation. Now I'd like to introduce James.
All right. Hello, everybody. Like I had said earlier, my name is James Meese. I am the Illinois manager for the RCAP program in our state. And we're going to be doing something a little bit different here. It's an introduction to alternative wastewater solutions, which basically is kind of talking about cluster systems, or decentralized cluster wastewater systems. Is anyone here kind of familiar with the concept? They're becoming a little bit more popular on the East Coast and the southern part of the United States, but they are moving their way to the central part. So basically, and we'll go through the basics, but this is a quick overview. What we're talking about is instead of doing a traditional wastewater system where you have one main treatment plant and you're doing all your processing there, you're breaking that up into very small clusters within an area. And then you're either pumping all of that into one place, so there's one effluent coming out, or you have kind of several effluents coming together and being discharged at a different spot or a different main location. And we'll go through kind of the benefits, but the main benefit that we'll have here, and we see a lot, is if you are in a community that is looking to redo their wastewater system or put one in, especially in these rural communities, they're going to be significantly cheaper. These decentralized cluster systems usually run about a fourth of the price of what putting in a traditional sewer system would look like. So, I mean, that's, when we talk about the benefits, that's kind of one of the main ones. Also, a lot of times they require far less maintenance because so much is happening already within the system and through the ground. Even leaving some homeowners' household, a lot of that waste is already being treated. And as it kind of goes through the system, a lot of that treatment has already happened, and the pre-treatment, helps reduce a lot of that cost. That being said, I was this close to getting one in the state of Illinois. We are still kind of actively working on it. The project's a little slowed. Finding engineering for it is not the easiest thing in the world right now, and that no one's at fault for that. It's just that they're such a new concept, especially to the Midwest, that finding individuals who are kind of super familiar with it does become hard. Also, when talking about permitting, that becomes kind of an issue as well, because everyone says we can permit them, but we have to figure out how we're going to permit them. So again, some of that's, but a lot of that language is changing, and I think as we see them becoming more and more popular, and as they kind of start to grow, especially for the cost alternatives, they'll be growing. I mean, when you talk about cost, I mean, as you all know, the cost of wastewater went through the roof with COVID. I had a community near me who, pre-COVID, their bid for putting in a new wastewater treatment plant, they're unsewered, so putting in everything was going to be about $9 million. They went through the grant loan process. Unfortunately, COVID hit. After COVID, the lowest bid they got on that project was $15 million, and they thought that guy couldn't do it for that price. So, I mean, as you can see, the costs are, starting to gain. So any sort of solutions or alternatives that we can see moving forward with these are become beneficial. Again, here's who we are. Kind of went through this. Here's our map. More of our services, just a quick refresher. We do have cards over here. There we go. All right, so small community wastewater challenges demographics. Again, we're looking at these smaller communities, unincorporated areas. HOAs also could severely benefit from these as well. Especially, we're kind of seeing an upkeep of HOAs that put in lagoon and sewer systems at some point in the 60s and 70s, but now they're starting to fail. And unfortunately, those HOAs or those neighborhood organizations are not being able to have the funding to be able to kind of upkeep those lagoons or redo them or any sort of wastewater system that they may have. So kind of looking into an alternative for them as well. Smaller populations and in no growth areas. Again, your geography is going to be very big on this. Two, is regionalization being prevented? Can you not pump anywhere? Are you located in a floodplain? And also your finances. And again, that's going to be kind of our major part in this. So here you can kind of see our example of our conventional centralized system. Everything's there. Everything kind of flows through it as opposed to our decentralized system. There on the right, looking at it there, you can kind of see where those small clusters are. Everything's a little bit more broken up. And again, that allows for, more treatment and lower costs and less maintenance. So again, here is kind of a diagram of it. You have your individual homes, then your small clusters, your large clusters, and then your small WWTPs and your large POTWSs. So again, kind of talking about your community vision, and again, this is going to be focused on rural communities because that's who we work with. But potentially, I could never see a whole city using one of these, but I could see neighborhoods within a city have these type of systems. So if you have an area that might be a little bit more isolated, or like I said, an area that is kind of on the fringes, or an HOA or a subdivision that was built a little bit far out, but now is starting to become incorporated into the city, but that sewer system isn't there yet, these could be used for them as well. So the bottom line, the approach, it's the economics. You want to maximize your economic value. You want environment, you want to benefit the environmental and society, society there as well. You want to make sure that you meet those objectives and that basically at the end of the day, everyone is able to get rid of their wastewater in a clean and proper way. If you do have any of these water-dependent industries, you want to look at your contaminants as well and your peak gallons per minute within the industry. Again, especially in rural communities, if this is your only industry or the only thing happening within the city, it's something you want to be aware of just so you are aware of how many gallons are flowing through the system. Again, you want to, food for thought, paying to move sewage versus paying to treat sewage. Increasingly looks to reduce flows. Sewer collection systems are viewed by some as mile-long liability and limit potential of I&I in clean water entering the sewer is always things that you want to take into thought, especially as we kind of start looking at these systems. So is your community's land appropriate for an alternative wastewater system? Obviously, that's going to be one of the first questions that we have to ask, because if your land is not and your topography is not going to work, we need to, maybe think about something else. But sandy soils efficiency is impacted by the strength of the waste. You can safely move more water, but it must be lower strength waste. So again, you're going to have to look at your waste strength within that in your sandy soils. Clay soil, which we see a lot of here in the state of Illinois, it handles high strength waste well, but clay makes water transmission difficult, so a large dispersals area is necessary. So again, if you do put in one of these cluster systems, the dispersal area, you're going to have a large area once that dispersal does place. So. Common features in an alternative system: salvage existing on-site systems that work. So this would be possibly taking in any sort of septic tanks that homeowners may have already in there. And can we salvage those and kind of put those into a cluster system that we're building as well? One of the big things that we always hear, especially when we start talking about sewer system, is I just paid 10 grand to have my septic tank fixed or pumped, or 20 grand to have it put in. What do I need to do? I'm not going to join your sewer system. So this way, it's the best of both worlds, that, that individual who has done everything right, who is keeping up their septic system, who's not allowing it or running into failure, can continue to, harness that and, get the value out of their investment, but is also now being tied into a much larger sewer system. Problem areas become cluster systems are better on-site systems. Soil dispersal and reuse opportunities. Again, you want to look at surface discharge is the least preferred. So that's what we're going to try to avoid there. And cluster collection systems equal more passive treatment facilities. Again, so you're going to have a little bit less treatment facilities in these cluster systems because a lot of that treatment is being done within the soil or before even leaving the homeowner's home. So why an alternative wastewater system? We already talked about some of these, but cost is going to be your biggest one. It's going to lower project costs, and it's much lower operation maintenance costs as well. Once they're put in, they basically kind of run themselves. A lot of them, you would want to need a wastewater operator on site, but they're not. The day-to-day activity is going to be severely less than if you were running a traditional wastewater treatment plant. The simplicity as well. So again, they have a smaller environmental impact. They're easy to operate. Kind of once again it is put in and employs the most passive technologies. And looking at efficiency, it maximizes soil dispersal and reuse opportunities where possible. And it targets the biggest problem areas and minimizes infrastructure investment. So again, we're investing in the infrastructure, but we're minimizing what we're doing. We're not putting in that larger wastewater treatment plant. We're using what we already have. We're tying into the smaller parts of the community, or we're looking around to see what exactly is happening. So benefits of funding a decentralized sewage treatment plant. Decentralized systems can be planned and installed quickly. Site evaluation conducted, and manufacturers have designs already available. And loans can be directed to homeowners through local government or non-for-profits providing wastewater services. Again, that would be one of the ways that you could help get it funded, is possibly going through the individual homeowners as opposed to a government entity taking out the loan. And the speed, like I said, if you do have one and everything works out well, they are fairly simple to put in once you kind of start moving it, once you get the ball rolling on them. Again, you keep costs on your short leash. You pay as you grow, or right size just in time. So again, these allow for more growth if you do have a community that does begin to grow or even begins to shrink a little bit. These allow for a little bit more of that, so you're not worried about your maximum capacity. You're not worried about what is going into the system, because again, you're basing a lot on what the homeowners are already doing within their house. So quick fact check, alternative wastewater does not always mean replacing septic tanks with new ones. Again, we can kind of take some of those septics out. Can meet EPA discharge requirements. They can be permitted, you just need to work closely. And not a short-term solution. They will last as long as conventional systems if properly operated and maintained. Remember, community is the customer. So, again, if you do look into these, just speaking with the engineers about what you want and really just kind of informing them about it. Like I said, when we had one of these going there for a while, finding the engineering firm and explaining it to them was one of the things that we ran into the most. And that is something that RCAP can come in and assist with as well. We have some familiarity with these systems. I've been to a number of trainings on them throughout the country. So, just kind of understanding what they are and kind of explaining that and what resources are out there for them is going to be paramount to being able to have a successful project within this. So again, few experts in both. You got, your experts in your conventional centralized systems and your experts in decentralized. So finding that mix is kind of one of the things that we want to look into. Look at your wastewater status quo. Most wastewater infrastructure planning is done by experts in the centralized system. We understand that, but we also have to start understanding that maybe we do need to look for alternatives for these smaller rural systems, these smaller systems on, these smaller systems with failing wastewater infrastructure, kind of as we move forward. What are we going to do if regionalization is not an option, if we cannot tie them in? Then we need to start looking at, something that is affordable for the community that they can help run long term, and this is an option. Determinants of technical success. Again, proper sitting and design, ongoing proper use and care, and proper installation. These are going to be your three main ones. That design kind of speaks for itself. if it's not designed correctly, obviously it could fail. But making sure that design is going in, making sure that it does have room for growth, making sure that it also has reduction for population as well in that capacity. Ongoing proper use and care, like I said, that is one of the super benefits of these, that they are fairly self-running. But that being said, you're going to have, obviously, with anything, some operation maintenance. You're going to want to make sure that you're doing your research, your asset management planning with them. You know how old everything is within the ground. You know how old the components are, and we're planning for replacement as they go. Also, if you do go to the route where you're already tying in some older septic tanks, or you're using a septic system to join in the cluster, you want to kind of write in who's going to be responsible for that once it does start to fail, and making sure that an ordinance is put in that it's either going to be on the homeowner or the runner of the system as it, whatever pertains to what you decide. And again, proper installation speaks for itself, but you want to make sure that everyone's licensed and you have that installation is done properly, and that you're not going to have any issues kind of running through once you get up and running, because the last thing you need is something to get tanked as soon as you begin it. Compliance and management, managed like any other utility. You're going to have your discharge permits, you're going to need those, so you'll need your wastewater operator to be on top of that. You'll be working with the EPA for what exactly the discharge permits are, and rate adjustments as well. So again, you're not taking away the bill from these. You are going to be billing customers monthly for these systems, and it's purely because you need to be able to afford new ones. You need to be afford components. You need to be able to afford staff. So, it's not a one thing, and we'll never get a bill again. No, but you could reduce those bills, especially if you have a lower debt amount, or if you're running far less chemicals, power, that type of thing within there. Those rates will be, you can lower those rates, but there will be rates, and you'll have to do rate adjustments on a yearly or biannual basis and work with it. So I'm talking about limits of affordability. About 80% of U.S. households have sewer, but what does that mean is that there are 20% of communities out there with no sewage disposal systems. And we see there's quite a few unserved communities that I'm aware of in the state of Illinois. Again, I live in Logan County, which has some significant rural areas. And those we've seen, I know about 4 or 5 communities that no sewer whatsoever. So kind of, thinking about it. So this is just, a quick example. If you have a project cost of $4 million, there are 89 potential customers proposed for the project. We see this all the time. You have a small community. What are we going to do? That is about $45,228 per customer. If the median household income of the community is, places less than $17,000, that's fairly low, but I have seen it before. So just looking at the affordability of this kind of breaks it down to what some communities are facing. Most, especially that 89 customers and a $4 million cost. What are we going to do? How are we going to afford this? What alternatives are out there to be able to do this? Because the last thing we need is to put in a system and then have people not be able to pay their bills. Because that's when everything kind of starts to break apart. Especially if you take out a grant loan for this, you're going to be able to need to pay that back over the course of the years. You're going to want to be able to keep up with that operation and maintenance. Deferred maintenance is going to be the worst thing that you can possibly do on any sort of system, especially if you don't have the money for it, then you're going to run into much bigger problems. So basically, that was kind of one of the examples there. So what is affordable? U.S. EPA considers the average annual residential sewer bill up to 1.5% of the median household income. Is typically what we do. We do between 1.5 and 2% when we're looking at rates for individuals. So, that's kind of thinking about your community as well. looking into that, what is that 2% of your median household income? I will say most of the time I find that 2% is right on par or not going to be a little bit higher than what most sewer bills are for already established systems. But one, a lot of times those communities are not having a high enough rate, so they're actually losing money on their water wastewater system. So while their current rate is lower than that 2%, they're not quite there. And so they need to raise it, and those newer systems that are going to be far more expensive are going to surpass that 2%. So again, this is just a quick breakdown of your MHI. What is the affordability? Lower numbers here, but we do see some of those in the state. So median household income does not represent low-income individuals as well. So again, the key to that is the term median. So that is going to be in the middle there. So I mean, if you're going to have obviously a significant portion of your community below that. So what do we need to do to kind of help them out, and what systems can we do to be able to help them? So look at your policy questions. How much is reasonable to expect households of limited means to pay for these essential services? We want everyone to be able to pay, obviously, and we want everyone to be involved, and we want our bills paid. But how much is too much? What do we need to do to kind of look into this? So again, looking at some of your proposed criteria here, 10% of the disposable income for the 20th income percentile. So how much are we going to be able to pay to work within that? And this training needs to be updated, so we hit that $15 mark. So again, looking at what makes up your end user costs, the original project costs and debt. How much is it going to cost to be able to put the one in? Like I said, I had that one system at $15 million. They, I think, had less than 150 customers. They're not going to be able to afford that from the very beginning because they're taking on that cost and debt. And unless they want to pay $150 a month for a water sewer bill, which I know the residents would not be happy about, what do we need to do? Ongoing operation costs and reserve funds for savings in the future. Having that asset management, having that plan, having the ability to kind of capital improve, to think about growth, or just think about what we need to do to continue to run this as efficiently as possible. So having those reserve funds and savings for the future are one of the more important parts. So again, just looking at your big pipe versus alternatives, your original project expenses may include property assessments, loan debt payments, loan debt reserves, expenses and debt to demo and disconnect from existing on-site systems. Again, your on-site operation costs, you're going to have your labor, your utilities, your fuel, your sludge disposal, your emergency repairs, IT, and permit renewals. And then obviously your reserve funds, what you have in there to be able to save for that lifestyle costs. So again, this is just looking at an example of a decentralized project. So how much financing were they able to save? They were able to get it down to a significant amount cheaper by looking at the decentralized system as opposed to the traditional system. So again, looking at, this is a true picture of the total lifestyle costs. Currently, this example of this town is fiscal emergency because it could not pay its loan payments for a 12-year-old sewer system. So they're already they're only 12 years into a 30 to 40-year term, and they're already, already losing it. Their monthly rates are already at $55 a month with increasing. So this is kind of what we're talking about. What does the system need to do? How do we avoid situations like this? So again, rates are always going to be the biggest thing. With finances, especially working with municipal boards, they don't want to raise rates, and we understand that, but what do we need to do to be able to explain and help keep those rates down as low as possible so they're equitable and everyone can afford them? So again, considerations when selecting affordable alternatives, your topography, geology, land use, population distance, and land features. So decentralized preconditions. Again, you want to see how many connections do we have. Obviously, if you have a large portion of connections, these might not be the rate to go. You want to kind of look at your smaller systems as well. Do you have any neighboring wastewater treatment systems? If so, is regionalization a better option than looking into these? And what types of failures could you have there, and what could run into that? So again, looking at your technology costs as well, your centralized systems. There you have kind of your total capital costs. Centralized systems, you're probably talking between 2 and 4 million. Alternative systems or on-site systems, you can see there you're significantly less. Making up a significant amount of money there on your O&M costs. And looking at the average, house per household, or you can see there. So again, I don't want to say, I keep harping on this, but they are cheaper and they are more reasonable. Again, once you kind of decide if you want to do that, you want to look at potential partners to see what can be done. You also want to reach out to community members to see if it's something they're even interested in, because if they tell you no, then obviously it's not going to work from there. So what systems should consider? Physical condition of potential partner facility. And treatment capacity, how much capacity does each system need? Geography as well. So interconnecting of two systems may be unlikely if the distance between the two is too large or interconnection is too costly. So again, if you are thinking about that regionalization idea, with the as opposed to the alternative system, you need to kind of think about what those need to be considered. Geography as well, is it even possible? Obviously, your adequacy of supply as well. If you don't have enough, if you're not sufficient, and then it's not going to, that's not going to work as well. Also, our state policies, always work with your funders, always work with EPA for anything to be able to see if anything is even possible. So common wastewater problem areas identified. We have collection, treatment, I&I, sludge handling, and nutrient reduction. Collection there. Centralized collection solutions, collection systems, gravity sewer with pump stations. You have low pressure, septic tank with a fluid pump, grinder pump, and septic tank with a fluid gravity are kind of some of those basic centralized collection systems that we run through that we see. Gravity sewer with pump stations. You got your cons, high capital costs, subject to infiltration. Pros, they're reliable with less maintenance and lower long-term O&M costs. Low pressure step and grinder systems. Pros, they're shallow collection lines with lower capital costs, less subject to infiltration. Cons, high O&M costs due to pumps, a number of pumps, and possible odor corrosion issues as well. So yeah, some of those grinder pumps can cause an odor once you kind of start putting them in. So if you're thinking about using those in one of these decentralized systems, then always something to consider and figure out what we need to do to mitigate that. Septic tank with effluent gravity. Cons, possible odor and corrosion issues. Pros, small diameter and shallow collection lines, and lower capital costs and elimination of manholes. So again, you've eliminated those, you've eliminated more infrastructure putting into the ground, which will again then keep your costs lower. So again, just kind of looking at a matrix of what we just went over, the benefits and everything. And we can always share this presentation with you afterwards if it's something you're interested in. So looking at your treatment, you have your primary treatment here. Then you're going to go through there into your secondary treatment. And finally, you're going to, discharge there. So this gives you kind of a basic example of how a decentralized system would work and how everything would flow within there. Like I said, you got your primary treatment coming out of the household for the most part, running into that secondary treatment, what we need to do, and then finally your final there. So, your centralized treatment solutions, you have your conventional, you have extended aeration, oxidation ditches, property package treatment system, lagoons, and membrane bioreactors. So again, looking at the pros and cons of conventional systems, I'm sure you're all aware of these. So film treatment systems as well, kind of giving you a basic example of that. Lagoons, we just went over those. There we go. So looking at a little bit of the I&I too, kind of thinking what do we need to do with that. Removal versus treatment. Many funding agencies require the most cost effective, so you want to also consider the life cycle costs. So again, some of these decentralized systems can help reduce your I&I significantly. So kind of one of the benefits there as well, because again, a lot is happening within the system itself in the household. I&I solutions, you have your removal methods. You have your lining treatments, above below grade, concrete, steel, and lagoons. Talk about sludge handling solutions here. Filter bed systems, you have your sand, you have your interlocking media tiles, gravity flow systems, Wastewater, Roberts filter groups, belt presses, and rotary fan presses. I will say one thing nice about these decentralized systems as well. It is a lot harder for a farmer to tie a field tile into it. I've run into recently 3 or 4 systems on the rural side who are convinced that there is field tile tied into their wastewater systems. They just don't know where it is. One of these, that it would be significantly harder to do in the decentralized cluster system. So, talk about interlocking media tiles, the advantages and disadvantages. The pros are low capital costs, non-mechanical parts, base of operation, and low maintenance costs. Cons are sludge, can freeze in the winter, several days to achieve the percentage of moisture matching mechanical methods. Talk about the belt filter press. Again, your pros, sludge cakes with higher percentage solid content. Cons, can require operation attention. Sludge must be screened well to prevent belt damage and significant use of water. Again, rotary fan presses. So talk about nutrient reduction there. Again, what do we need to do with nutrients? In decentralized systems, this does become significant as well to be able to reduce those nutrients, especially because you could have higher amounts coming out of that first system or the households as well. So those nutrients might be significantly higher than what would be going through a traditional wastewater system. So what do we need to do to be able to, to reduce those as they go through the decentralized cluster system? So you might want to be able to add chemicals, some phosphorus, and enhance biological phosphorus removal. Again, the chemical additions, pros are a simple process. It's most common, especially for smaller wastewater treatment plants. Cons, increased sludge production and higher O&M due to chemical costs. So again, if you're worried about chemical costs, it is going to kind of drive up some of that price, but it is possibly going to reduce some of the nutrients that you have going through there and some of the future issues. So it's something you need to balance. Again, phosphorus removal, enhanced biological, lower O&M costs. Cons, higher capital costs again. So talking about management and regulatory solutions within these. With these, like I said, we have a lot of regulatory elements to these. So this is where it becomes key, kind of working with the IEPA and your engineers or anyone who's worked with these in the past to be interested on what we're going to be doing with them. We know what they are, we know how they work, we just need to kind of figure out what we're doing to be able to get them completed and get them funded and have them properly permitted once they're put in. So again, kind of looking at the responsibility matrix of who are going to put these in, who is in charge. A lot of times too, you do want to bring in your local health department who's done permitting for the septic. Once you kind of move these in, since you're converting from, if you're converting from septic to a traditional treatment plant, the county health departments are going to have the majority of that information. on hand and what needs to be done within there and how that conversion will work and what permits are needed. So, again, a septic system or any really system without operation, O&M will eventually fail. So that's kind of what we're talking about here, is that when we put in those, if we do put in one of these conventional or non-conventional decentralized systems, and we do that all alternative, what would the O&M be? And how do we need to be able to fund that, and who's going to be in charge of that? That's where the permitting kind of becomes super important, and the ordinances within the system and how it is structured becomes kind of a lot of the questions that we're kind of trying to move forward with. Again, who's going to be responsible if it fails on the homeowner side? If you do tie in, is it who, what, if we are paying rates, are those rates going into a pool that will help collectively help everybody? Are they just going into the basics of the decentralized system and kind of where they're going? We've seen it every which way that you can on that one. So I would like to, I can't tell you one way or the other that works the best. But really, like I said, if we're seeing, if you're doing a rural area, creating a sewer district, that is going to be responsible for the system, kind of, is one of the big ones. So again, we're talking about responsible management entity. That's going to be who's going to be in charge for that, the RME. So they're going to be in charge of the O&M, the financing, and the monitoring and reporting. So again, like I said, we got, every which way we can go through on the management options and who's going to be kind of in charge of it. You can have a public authority, public non-for-profit corporation. If you're in an unincorporated area, we see this quite a bit, where a non-for-profit is created. Again, not on here, but HOA or homeowners association, which falls into one of these a little bit, kind of goes in that as well. But basically, we want to figure out who's going to be responsible for this thing, who's part of the maintenance, and what do we need to do to run it properly. So entities that can serve as RMEs, county boards of health, homeowners associations, public water systems, rural cooperatives, or watershed districts. So again, those are the ones who can kind of run it. It just depends on how you want to structure it if you do start to create one. If you already have an established system and you want to convert to one of these, obviously you're going to be looking at, probably a public water system. Now, if it's something brand new or, like I said, not in a particularly incorporated town, we need to start looking at other alternatives. So that's just the law on that. Nothing, I'm not going to bore you with all that. So. Again, we want to kind of think about the types of management we have. The environmental sensitivity, the public health, the wastewater characteristics, and the treatment complexity. So again, homeowner awareness going to be kind of number one here. Is the homeowner, one, even aware they're a part of this? Two, if they are aware of it, what are we going to do? Talking about, again, those maintenance contracts. How are we going to how are those going to be subjected? How are those going to be created? Who's going to be responsible for those contracts? Operating permits. Making sure that everything is permitted properly. And ownership, ultimately, at the end of the day, who owns the system? Who's responsible for what? How is it going to be billed? How are we going to be saving the money? And how are we going to be able to get funding for this? So again, each one of these does have a level of risk. Going through these, we can go through these one-on-one if something that you're interested in the future. So success hinges on proper O&M. Imagine a wastewater treatment plant without an operator. This would be the same exact thing. If you do, put in a decentralized system, imagine there being someone who's not going out on a regular basis, checking to see if everything is running properly, if everything is being done up to code and doing what they're supposed to. So again, kind of thinking about, why the status quo isn't working. And it's not working purely because people, one, your traditional systems are becoming very hard to afford. And two, keeping people on traditional septic systems is not always the best as well, while they do run very well. let's face it, a lot of homeowners are not the most responsible. They're going to either not pump or they're going to continue to run those to the point where into failure or have issues. So that's kind of what we're talking about here is what do we need to do with these to be able to create a system that will allow an RME to come in and make sure that everything is handled properly for everyone within the community. So 3 reasons to address failing septic systems: 1, environmental health, obviously, human health, and property rights, failure cost burdens as well. If your septic system fails and it runs into your neighbor's system, what are we going to do? How do we do this? And again, these decentralized systems are a way to kind of help start and avoid some of these main issues. So if you are in a community or you're working with them or thinking about it and they're thinking about putting in a new sewer system, here are some of the signs that some of the septic tanks in that community might be failing. So you have your pooling, taste and odor, high bacteria levels, algae blooms, and low dissolved oxygen concentrations. I will do another plug for RCAP as well, that if you do have one of these communities and they need their water tested, let us know. We might be able to assist them with that as well. So again, here's a list of pollutants. Where there's harm, basically we want to make sure, obviously wastewater can be harmful to humans, and that's what we want to be able to make sure of. So how can we address these problems? Inspection process, obviously. Even once you put in the decentralized system, you want to be able to do an inspection. You want to make sure we're avoiding all of this as well. Operation maintenance on-site numbers. 20 plus years of continuous operation. You want to replace components periodically. Component replacement, 6 to 9% of O&M costs. So again, we want to look at those filters and membranes, those pumps, those valves, those meters. We want to be able to have an asset management plan so we're aware of what is actually within the system and what we need to do to be able to keep that going properly. So again, looking at our leverage points here. Where are the property? What do we need to do to be able to do that? And what do we need to do once the system is put in so we can continue to manage it properly? So considerations in the planning process. So again, you want the community and customers to buy in. Again, you don't want them having something that they're not aware of or what they're even aware of what is happening. You want community partners and specific problems definition. So you want to know, what is the problem? What are we trying to address? Are we trying to address failing septic systems? Are we just trying to address a lack of sewer treatment altogether? Do we have a sewer treatment plant, but it's currently failing, and now we're looking into an alternative? Basically, what do we need to be able to do? Community profile as well. You want to look at the socioeconomic and statutory assets for the risks in the future. You want to see, is the community growing? If it's growing significantly, some of these issues for a decentralized system might not be the way to go. You might want to look at a more traditional system because you're seeing a significant amount of growth. At the same time, if you're seeing a lack of growth and shrinkage, if the community is shrinking, what do we need to do to kind of address that, and how do we need to plan for that in the future? You want to look at a feasibility analysis and implementation of monitoring indicators of success. Funding sources, how is this going to be funded? That's always kind of one of the main ones. We can kind of go through the individual ones with you here. But basically, all our main sources in the state of Illinois, I believe, will help fund these. So again, looking at some of the theories here. So you want to avoid the cost of decentralized wastewater systems by treating near the point of generation. So again, as it comes out for that homeowner. Several small conventional centralized systems, several clusters, and on-site systems. So that's kind of what we're looking at when we're talking about these decentralized systems. So you want to avoid high costs of interconnections and choose appropriate decentralized system according to development density, site conditions, and waste characteristics. Again, we had talked about this, but how much is it going to cost? we run into a lot of rural communities. Cost is kind of one of their main things. Again, thin TMF, part-time mayors, city councils, in charge of this. So who's going to be in charge of the decentralized system? A lot of times in rural communities, you have volunteers. So what do we need to do it? An army is more than just operation maintenance. Obviously, there's going to be more. You have to be in charge of training your employees, hiring your employees, making sure everything is run properly, permitting, those things. So again, common pushes towards that. Fatigue of local managers. So again, having a responsible management entity in charge of these, a little bit different than someone going through your traditional route. And again, a few examples of those. So, talk about your financial structure, your initial costs. How much is it going to cost to go through there? And then you're going to have your ongoing costs, centralized management, local utilities, and your daily O&M as well. Strategies for publicly owned RME structures, utility districts, and cooperatives. Again, these are kind of one of the ways that you can set those up and represent those. Again, then private joint ventures as well. So talk about in management plan. So once you do start to put these in and you have your RME established, what are you going to do? Inventory of systems and conditions, inspections by a professional at least once every 3 years. So you want to have a professional out there who will inspect the system on a regular basis. I would suggest probably more than that, but it says at least. I would go a little bit more than that. Tank pumping every 3 years as well. So you want to make sure that everyone is on a tank pumping schedule. Because again, the last thing you need is something backed up. And again, that is be the question of how is that going to be funded, and that will go through the RME structure. Proper wastewater disposal techniques, septic drainage field care. Are those drainage fields being taken care of? Are they doing it properly? Fee rate structure for both residential customers and sewage disposal. And policy on new builds that minimizes health risk on leverage and economic scale. So again, this kind of giving a basic example of how much they cost and what we can do there. So again, kind of looking at this, this is an example here. We had several tribes up in Wisconsin who were thinking about one of these, who put them in. They're located within this larger area, so they're 30 miles away from each other. So, we're here, and here. We're not really centralized within anything. So what can we do? So they basically started putting in this decentralized system. Again, there is going to be your basic example of a decentralized system. Sewage system is defined as the collection, treatment, disposal, reuse of sewage from individual home clusters of homes, isolated communities, or institutional facilities as well, from portions of existing communities or near a point of waste generation. So again, I know, but that's kind of what we're talking about, is create these clusters, or what do we need to do where we're getting them collectively and getting everything together. They're effective and economical. They consist of many different approaches to treating wastewater lagoons, back reactors, and clarifier treatment. This was one of the ones that they had put in, just an example of one. It is one wastewater treatment plant, primary clarifier, 3 lift stations, gravity sewer lines, and 11,000 forest main lines. So, kind of this is what we can do with them. So the advantages of the decentralized systems, again, they're given the smaller flows of sewer size, also smaller in depth and cut are also less than making it easy to construct and manufacture. So again, that's going to be a big one too. We can get them up quicker. We can get them running. They're easy to construct. So again, as we kind of spread out in these communities, operation maintenance becomes an issue. This way, if you do have several communities who put one in, you can hire one possible operator to take care of everything, as opposed to having several different ones. All right, and that's all I got on decentralized systems. I know we went through a lot of information there, But if you guys have any questions about them or want me to go into more detail or anything, feel free to reach out. I do have cards over there. That's basically all I got.
I would just add one thing with the decentralized systems for this group. The idea that they're pushing forward is instead of having one giant class 1 plant to collect over a large area in some of these rural communities, they're pushing for smaller, more itemized treatments, whether they're RCBs, small can systems, things along those lines. They're generally cheaper to run in the long run. They generally take less energy, so they cost less to build, they cost less to operate, and that's why this idea is being pushed forward a little bit more on the rural side. So that's the ultimate of this.
Yeah, like I said, they're becoming very popular on the East Coast, especially in your smaller states, your Massachusetts, your Rhode Islands, where basically they're out of room to put in traditional sewer systems. And a lot of people are on septic because of the topography out there. But the septic tanks are also now starting to fail. So what do we need to do to kind of, alternate for the alternative there? And that's where the idea kind of grew out of as an East Coast idea. But once they realized how much cheaper they were, then that cheapness basically allowed for them to continue to kind of build within that capacity, and that's kind of what we're seeing, the expansion westward with them.
They're actually in the East Coast reviving some of the old wastewater technologies and off tanks and treatment buildings in some areas to handle this subdivision. Or incorporate the new like RCBs. So
And like I said, I think with the rising costs and a lot of sewer treatment systems that were put in that have not been run properly over the years with, operation maintenance going down, I think we need to find a solution here. And I think, these are a possible solution for everything. So.
Well, thank you very much, James and Tony. We appreciate you guys coming down here. That concludes today's meeting. If you need certificates, if you watched it on YouTube, please email jnaylor@gpsd.org. Thank you.